Today we are starting our unit on trig. This is our unit on trigonometry basics. So we're going to begin discussing angles. Angles can be measured using two different units, degrees and radians. Radians are very convenient for a variety of reasons, and in calculus we use radians exclusively. Our derivative and integral rules are only valid if the angle is in radians. So let's talk about converting. We would like to know how to convert from radians to degrees, degrees to radians, and so let's review just how to convert units in general. We would like to know how many seconds are in 1 year, assuming that it's not a leap year and there are 365 days in the year. Well, there are 365 days in 1 year. So I can set up the ratio 365 days is 1 year. We'd like to change that to seconds in 1 year. So I don't want to change years, I do want to change days to seconds. I know that there are 12 hours in 1 day. I would like to get rid of the days, so I want days to be on the bottom. And there are 24 hours in 1 day. My day units cancel, and now I'm left with hours per year. If I multiplied 365 times 24, I would have hours per year. Okay, I know that there are 60 minutes in 1 hour. I want to get rid of the hours, so I'm multiplying by 60 minutes over 1 hour. Our units of hours cancel, and now we have minutes per year. One more step, we know that there are 60 seconds in 1 minute, and our minutes cancel, and now we're left with seconds per year. All we need to do is multiply our numbers on top, multiply our numbers on the bottom, and we'll have seconds per year. So whatever we get when we multiply that out, 365 times 24 times 60 times 60 divided by 1, and that would give us seconds per year. Squeeze that in there. All right. Let's do the same thing. This time we want to convert 30 inches per second to miles per hour. And I'm giving you the fact that there are 5,280 feet and 1 mile. So we're starting with 30 inches per 1 second. We're starting with that. And we want to convert that to feet per mile. So we want inches to be converted to feet. I'm sorry, we want inches to be converted to miles, and we want seconds to be converted to hours. So this time we want two things going on. Let's focus on the inches first. Let's convert inches to miles. Well, I know that there are 12 inches in 1 foot. So I want to cancel the inches, so I want that to be on the bottom. There are 12 inches in 1 foot. My units of inches cancel, and now I'm left with feet per second. Okay. I want miles. So how many feet are in a mile? Well, there are 5,280 feet in 1 mile. I want to cancel my feet, so put that on the bottom, so it would cancel with the feet in 1 mile. Feet cancel. Now I have miles per second. I want miles per hour, so I need to convert seconds to hours. There are 60 seconds in 1 minute. My seconds cancel, and now I'm left with miles per minute. I want miles per hour. Multiply by 60 minutes in 1 hour. Our minutes cancel, And now we are left with miles per hour. We're going to multiply all the numbers on top and multiply all the numbers on the bottom, and we will have our answer in miles per hour. Miles per hour, mph. So that's how we convert using a little unit analysis, a little stoichiometry. Okay. All right, our conversions for degrees to radians is this. Our conversion for to get from degrees to radians or radians to degrees, we need to know that pi radians is 180 degrees. Pi radians is 180 degrees. So if we want to convert from degrees to radians, we use this conversion. So if I have 45 degrees, well, I want to cancel degrees, so I want degrees on the bottom. So I have 180 degrees on the bottom, pi radians on top, and 45 goes into 180 4 times. So this leaves me pi divided by 4 radians. Now, for degrees, we have a little symbol that means degrees. That means degrees, yes? There is no symbol for radians. There's not even an abbreviation for radians. So if you want to state the units for radians, you have to write it all out. However, if you don't write out the unit radians, it is assumed. Radians are so conventional that we don't even need to write the word radians, and it's assumed to be radians. So from here on out, I'm not going to write the word radians. It is just assumed. Unless they specifically ask me for units. If they specifically ask me for units, I need to write radians. But otherwise, it's assumed. Let's convert negative 50 degrees to radians. So I'm multiplying by pi radians to 180 degrees. The degrees cancel, and I can cancel out a 0, and then I'm left with negative 5 pi divided by 18 radians. Let's convert from radians to degrees. So 5 pi over 6, that's radians. So I need to divide by pi radians and multiply by 180 degrees. The radians will cancel. I'm left with degrees. Okay, these pi's cancel. 6 goes into 180 30 times. 5 times 30 is 150 degrees. Now, you must write the degree symbol. Otherwise, it's assumed to be radians, and we don't want radians. We want it to be degrees. Let's do the same thing for negative 5 pi over 3. Changing 2 degrees, so I want degrees on top. Pi radians on the bottom. Again, these pi's will cancel. 3 goes into 180 60 times. 6 times 5 is 30, so this is going to be negative 30 with a 0 degrees. Okay, again, you must write the degree symbol if your answer is in degrees. All right. Okay. Since we do work exclusively with radians, you must have a good understanding of how large they are and how they relate to their equivalent degree measurements, which you right now are more familiar with. Specifically, we need to know the radian equivalent of the angles, that's missing a little s, the angles shown on the right. Okay? So these are our degree measures, and we know that this is 0 degrees right here. It's kind of our quote starting spot, 0 degrees. And as we go, a right angle would be 90 degrees, all the way across is 180 degrees, etc. These are all the degree measures. If we go all the way around, we're to 360 degrees. Okay, let's do the same thing for those, but let's do it in radians. Okay, 0 degrees is 0 radians. 180 degrees is pi. That's our conversion factor, right? So this is pi over here. If this is 0 and this is pi, what is this up here? Well, it would be half of pi. We call that pi over 2, half of pi. Well, if this is pi, what would it be to go all the way around? 2 pi. So 0 is the same as 2 pi on this, when you're talking about angles, on the unit circle here, on this circle. Okay? Going all the way around is 2 pi. Okay, so what would this one down here be? Well, if that's pi and that's 2 pi, this would be 1.5 pi, or 3 pi over 2. All right. What would be the angle that's halfway between 0 and pi over 2? Halfway between 0 and pi over 2 would be pi over 4. What would be halfway between pi over 2 and pi? 3/4 pi, or 3 pi over 4. Okay, let's think about this. 0 I could think of as 0 pi over 4. This is 1 pi over 4. This is 2 pi over 4, which would reduce to pi over 2. 3 pi over 4. 4 pi over 4. What would be the next pi over 4? 5 pi over 4. And then 6 pi over 4, which reduces to 3 pi over 2. The next pi over 4 angle would be 7 pi over 4. And if we go all the way around, we would get to 8 pi over 4, which is 2 pi. What I drew in blue are all of the pi over 4 angles. Okay, next let's do, choose maybe green here. Okay. Now let's do the pi over 3 angles. Let's do the pi over 3 angles. So 60 degrees is pi over 3. If I take pi and I cut it into thirds, I would get these pi over 3 angles. Pi divided by 3 is pi over 3. This over here would be 2 pi over 3. If we go to pi, I can think of that, if I wanted to, as 3 pi over 3. If I go 1 pi over 3 more, I'll be at 4 pi over 3. 1 more pi over 3 would be 5 pi over 3. And if I go all the way around, I can think of 2 pi as 6 pi over 3. Those are all the pi over 3 angles. Okay, we have one left to hit, and let's talk about the 30-degree angle. The 30-degree angle is half of 60 degrees, and half of 60 degrees, half of pi over 3 is pi over 6. Pi over 6. So that is 1 pi over 6. Pi I could think of as 6 pi over 6. What is 1 less pi over 6? That would be 5 pi over 6. What is 1 more pi over 6? 7 pi over 6. If I go all the way around, 2 pi I could think of as 12 pi over 6. What is 1 pi over 6 less than 12 pi over 6? 11 pi over 6. So, these are the angles that I need you to know. Radian measures, I need you to know. 4 pi over 3, I need you to know. That's in the third quadrant. Okay? All right. that brings us to what are called coterminal angles. First of all, the initial side of an angle in standard form. In standard form, the initial side of any angle is always at 0 degrees or 0 radians. So this is the initial side of every angle. The terminal side is the other side of the angle. Okay? So we're going to, let's draw the 45 degree angle. So that would be right here. That's the 45 degree angle. 45 degrees. And that's good and fine. But what would happen if we started at this initial side, went all the way around, past 360 degrees, and then ended right here? Well, that degree measure would be 360 degrees plus 45 degrees. That would be 405 degrees. So 405 degrees is the exact same angle on this drawing. They are equivalent on this, on the graph here. They represent the same angle on this graph. They are called coterminal angles. Okay? We could start at 0 degrees and go around twice and end up back here. So we would take that 405 and add another 360 degrees. That would also be coterminal. Or we could start at the initial side and go backwards. And that would also be another coterminal angle. What would we be doing for that? We would be taking that 45 degree angle and subtracting 360 degrees. That would be negative 135 degrees. So a negative angle goes clockwise. A positive angle goes counterclockwise. To find coterminal angles then, if you're in degrees, if you're in degrees, you take your angle and you add 360 degrees. And you can do it repeatedly to get more and more and more coterminal angles. Or subtract 360 degrees repeatedly to get more and more and more coterminal angles. What if you are in radians? Well, if you're in radians, you add or subtract repeatedly 2 pi. Add 2 pi, keep adding 2 pi, or subtract 2 pi, keep subtracting 2 pi. Okay, let's write 6 coterminal angles for 30 degrees. Well, I'm starting at 30 degrees. I'm going to have 3 greater than 30 and 3 less than 30. So if I add 360 degrees, I'm at 390 degrees. That's my first coterminal angle to 30 degrees. If I take that 390 degrees and add 360, I will have, let's see, 750 degrees, my next coterminal angle. If I take 750 degrees and I add another 360 degrees, I will have, let's see, 0, 11, add the 1, 1,110 degrees. All of those are coterminal to 30 degrees. Let's find 3 less than. So I'm starting at 30 degrees again. I'm going to subtract 360 degrees. That's going to give me a negative 330 degrees. Another coterminal angle. If I take that negative 330 degrees, subtract 360 degrees, I will be at negative 690 degrees. One more, because I said to. Subtract another 360 degrees, and we get negative, let's see, 0, 15, carry the 1, 10. So 1050 degrees. A word of warning. Do not do this on these problems. Do not do this. Do not tell me that 30 degrees plus 360 degrees is 390 degrees, plus 360 degrees is 750 degrees, plus 360 degrees is 1110 degrees. Do not tell me that. Why not? Why would you not say that? Because if you do, you are telling me that 30 plus 360 is 1110, and that is a false statement. You are saying that each of these is equal, and they are not equal. They're not equal at all. This is not equal to this. So don't tell me they're equal. When you say that two things are equal, you are making a big statement there. Okay? So don't say these. Okay? Write it out. Okay. Next up, write 6 coterminal angles for negative pi over 6. So here we're in radians. So I want to add and subtract 2 pi to get more and more coterminal angles to negative pi over 6. So I'm going to add 2 pi, but I'm not going to write it as 2 pi since I have a fraction with a denominator of 6. I want to write 2 pi as 12 pi over 6. And that will give me 11 pi over 6. Coterminal to negative pi over 6. Take 11 pi over 6, add another 12 pi over 6, and we get 23 pi over 6. Coterminal. Take 23 pi over 6 and add 12 pi over 6, and we get 35 pi over 6. All three of those are coterminal with negative pi over 6. Now let's find some less than negative pi over 6. We're subtracting 2 pi, and we get negative 13 pi over 6. Coterminal. Negative 13 pi over 6 minus 12 pi over 6 will give me a negative 25 pi over 6. And negative 25 pi over 6 minus another 12 pi over 6 gets me to negative 37 pi over 6. All coterminal with negative pi over 6. Last example for today. In which quadrant, let me plug in here. Sorry, hang on just a second. My computer needs to be plugged in. Okay. Goodness. Alrighty. In which quadrant does 50 pi over 3 lie in? In which quadrant does it lie in? So in class I let everybody brainstorm on how to figure this out. And they had some good ideas. They had a variety of good ideas. What I'm going to do, what is going to make sense to the most students, is I'm going to take that 50 pi over 3 and I am going to find coterminal angles until I get to between 0 and 2 pi, which will be between 0 and 6 pi over 3. And then I'll be able to figure out which quadrant it is in. So I'm going to subtract 6 pi over 3 repeatedly until I get down to between 0 pi over 3 and 6 pi over 3. Okay, first up, 44 pi over 3. Now I'm going to take 44 pi over 3, subtract another 6 pi over 3, and we will get 38 pi over 3. 38 pi over 3 minus 6 pi over 3 will give me 32 pi over 3. 32 pi over 3 minus 6 pi over 3 will get me down to 26 pi over 3. 26 pi over 3 minus 6 pi over 3 is 20 pi over 3. We're getting there slowly. 20 pi over 3 minus 6 pi over 3 is 14 pi over 3. 14 pi over 3 minus 6 pi over 3 is 8 pi over 3. One more. 8 pi over 3 minus 6 pi over 3 is 2 pi over 3. We're between 0 and 6 pi over 3. Where is 2 pi over 3? Here is my thought process on this, you guys. Pi is 3 pi over 3. 2 pi over 3 is 1 less than 2 pi, 1 pi over 3 less than 3 pi over 3. So 2 pi over 3 would be in this quadrant. Quadrant 2. It goes 1, 2, 3, 4. Quadrant 2. Alrighty, so that is angles in degrees and radians. We also did coterminal angles. It's our day 1.